All right, so moving on to problem 12, part A. From the final exam practice, we want to find the exact sum of this series. It's an alternating series starting at n equals 0 and going to infinity. The terms look like negative 1 to the power n divided by 2n plus 1. So if we think about the terms of this series as actually being, all right, so we can write this series as n equals 0 to infinity, negative 1 to the power n divided by 2n plus 1. Of course, exactly the same thing that's there, but then also incorporating an x to the power 2n plus 1. Okay, with x evaluated at 1. And so if we recall that the Maclaurin series for the arctangent of x is equal to sum from n equals 0 to infinity of negative 1 to the n, x to the 2n plus 1 over 2n plus 1, which is something that we may or may not put on a formula sheet. May or may not be a good idea, but either way, it may or may not come up. So we want to evaluate this at x equals 1, and that will give us the value of this series that we're looking at from the beginning. So either way, we also have to recall that this series is convergent for the values of x between negative 1 and 1, including 1. So this formula is valid for x equals 1. And of course, from the beginning, we also notice that this is an alternating series. It's by the alternating series test, I mean, the absolute value of these terms is decreasing and also goes to 0. So it will be convergent. So, I mean, of course, it should be convergent. We're looking for the sum of it. But either ways, we can use the alternating series test to show that it actually is convergent, so it has a limit. It has a sum. So either way, we're going to use the fact that we know that this series that we're looking at is just equal to arctangent of 1. And so tangent of pi over 4 is equal to 1, so arctangent of 1 is just equal to pi over 4, and this is the exact sum of our series. All right, that finishes problem 12A for us.